Example 6.3.1. The setup for this one says a 1-year $1,000 T-bill is offering a 2% yield. What price must an investor pay if he or she wants to buy the bond today? All right, there's a lot of information packed in those few words there, and what we're going to find from here on out as we work through the rest of the chapters is that you have actually already been exposed to all of the time value money tools you need to be able to evaluate just about any time value money problem that's out there, really probably anyone. The hard part with bonds is that the vocabulary is really dense with them. They've been around a long time, and there's just a really dense, rich vocabulary associated with them. So you've got to be able to get from the bond description, which is what we have in this example, to a map of the actual cash flows. Once we get to a map of the actual cash flows, we're going to do the same thing that we've done over and over again up until now. We'll identify the type of cash flow that we're looking at, and then use the appropriate tool to solve for the variable that we want to solve for. So let's talk a little bit about bonds. We're starting with a zero coupon bond, and of course that's in the example title. We also know that it's a zero coupon bond because it is a T-bill. T-bill stands for Treasury bill, and these are U.S. government securities that have maturities of 1 year or less, and they are always what we call zero coupon bonds. What that means is we have two general types of bonds, at least two types that we're going to look at in this text, what we call kind of plain vanilla bonds. We have zero coupon bonds that just the investor buys it today and receives some cash inflow, or they buy it today, they experience some cash outflow, and then when the bond matures, which is the term we use to say when the last payment is going to be made on the bond, when the bond matures, the investor is going to get what we call the face value back. So there'll be one cash outflow today, and you get a face value back when this thing matures. In this particular case, that's 1 year from today. Could be any amount of time, but Treasury bills are always zero coupon bonds. The other type of bond that we'll consider is, you might guess, a coupon bond. And coupon bonds make periodic payments, typically every 6 months, could be annual. They make periodic interest payments along the timeline while the investor holds the bond, and then at the end you also get the face value back. So that's a lot that we'll kind of unpack as we go. Let's start mapping this one out. We're starting with zero coupon bonds because the cash flow structure is the simplest of all the bonds that we'll look at. Okay, so this one says we've got a 1 year $1,000 T-bill. That means that the cash flows, the timeline for this one, is going to be over just a single year. So we'll start by mapping out our timeline. So we've got today, time period 0, and then we have 1 year from today. If this is a 1 year $1,000 T-bill, we're going to look at this from the perspective of the investor or the bond purchaser. That means that 1 year from today, the investor will receive a payment of $1,000. And we call that $1,000 the face value of the bond. And we also call it the principal amount because it is the amount that was borrowed, less interest in some cases. We'll unpack that as we get to coupon bonds. Okay. The problem also says that this bond is offering a 2% yield. Yield is shorthand for yield to maturity, and yield to maturity has several definitions. The one that's relevant to us here is it is the discount rate that equates the present value of the bond's promised future payments. In this case, that's just the $1,000 payment 1 year from now, with the current price of the bond, which we're not given in the problem. In fact, we know that's what we're solving for. All right, so we'll say price equals question mark. So yield to maturity then is actually our discount rate that we'll use to evaluate bonds. We've been using a little r for discount rate up until now in our timelines. I'm going to continue doing that. Just yield to maturity is a more specific phrase, and it has a few more elements to it than just a pure discount rate. We'll get to that when we get to coupon bonds. For now, it's good enough just to think of it as the discount rate we can use to evaluate the bonds. So this guy's got a discount rate of 2%. So if we want to know the price of this bond, what we want to do is take this $1,000 future cash flow and discount it back to today. We'll discount it back 1 year at a 2% discount rate. And whatever we get there as the present value of that $1,000, that will be the price of the bond, because that's the definition of yield to maturity. It's the discount rate that equates the present value of the promised future cash flows with the current price. So given this information, we can actually find the price of the bond. Step 2 is to figure out what type of cash flow we're looking at. We've got a single payment at the end of the timeline that we want to discount back to present value. We're dealing with a lump sum. And so by now, I'm sure we've gotten comfortable with the idea that with lump sums, we have 3 tools available: the present value or future value of a lump sum formula, the time value money keys in the calculator, and the spreadsheet. As usual, we're going to skip over the spreadsheet just because that does not tend to be available during exams. And we're going to go straight to the time value money keys on the calculator. All 3 of those solutions, the formula solutions, the time value money keys in the calculator, and the spreadsheet, are in the text if you're interested in using any of those as well or looking at them further. So let's go straight to the time value money keys. I'm going to do my usual process of writing the keys out vertically in the same order that they appear on the calculator, just to make sure I don't miss anything. You, of course, are welcome to use whatever system makes sense for you. All right, so the number of compounding periods we're looking at here is just 1. There's just one year involved here. I over Y is our discount rate. This is where we're going to plug in our yield to maturity. In this case, that's 2%. And it is, of course, looking for that in percentage terms, so we'll put it in as 2. Present value is what we're looking for, so I'll put a question mark there. We don't have any reoccurring payments on this one. We just have the $1,000 payment at the end. So in this case, we could actually put the $1,000 either on the payment key or the future value key. Because N is 1, it doesn't really matter where we put it. Conceptually, it makes more sense for me to think of it as future value, so I'm going to put it there. And then let's plug these guys in and see what we get. We'll start by clearing out the time value money keys by hitting second clear TVM, which puts 0 on all 5 of the keys. And then I'll enter them left to right. N is 1, so I'll type 1 and press N to store it. I over Y is 2, so I'll press the 2 key, and then I over Y to store it. Present value is what we're looking for, so I'm going to skip over that for now. Payment is 0, which it should already have a 0 recorded there when we cleared it out, but just in case, I'm going to go ahead and record a 0 there to be sure. And then future value is $1,000. I'm looking at this from the perspective of the bond buyer, who is going to have a cash outflow today, and then will receive a cash inflow of $1,000 1 year from now. So I'm going to record that as a positive. You could just as easily look at this from the perspective of whoever is selling the bond, in this case the U.S. government, and then in that case the $1,000 would be a cash outflow. You'd record it as a negative, and you get a positive present value, but you get the same number either way. All right, we have 4 of the 5 variables stored. The calculator can solve for the 5th for us, and we're going to do that by hitting compute present value. All right, and we are getting a present value of negative 980.39. So that means the price of this bond, what the investor will need to pay if he or she wants to buy it today, is $980 and roughly 39 cents. So from the perspective of the bond buyer, if they were to spend $980.39 on this bond today, and then 1 year from today would receive a cash inflow of $1,000, the investor will earn 2% on that investment. In fact, just for, they don't have to do this, but just for the sake of seeing a little more about what's going on, let's calculate the future value of that $980 at 2% interest. So if we take that $980.39 and then grow it by 2% so that the investor's wealth increases by 2% over the period of 1 year, let's see what we get when we do that. So I'm going to use this more precise value that's on the calculator. I'm going to say times 1.02 equals, and we get exactly $1,000 back. Again, not necessary, just to sort of reiterate what is going on here and what we're doing when we find the price of the bond by discounting the promised future cash flows at the yield to maturity, and that relationship runs in both directions.